Hello everybody, this is the notes for calculus, section 3.1, but the second part of that. So in the first part we talked about the idea of what a limit is. It's what the y value is approaching as the x value gets closer to a number. So what we did in the first part is looked at graphs. We looked at the graphs and we looked at tables. All right, so now what we want to talk about is being able to find the limit from an equation, like it says up top here. So there's two parts to this. The first part is, like it says right here, the limit of a function as x approaches a number. Okay, we're going to talk about it as x approaches infinity in a little bit here, but there's three steps, sort of. You kind of want to just try the first step. If you get an answer, then you're done. Okay, that first step is plug in the value of a. So you're finding the limit of this function as x approaches a. Plug in that number. If you get an answer for that, if that number is in the domain of the function, you'll get a y value. That's your limit. If you don't get a number, okay, some functions have restrictions. If you don't get a number, then you go to part two, simplify the equation. Like it says, cancel out common factors if you're dealing with a fraction, a rational function. There's some factoring you can do, some kind of uncommon factoring, and I'll show you what I mean by that. And if that works, fantastic. Once you simplify it, you go back to part one and plug in that value with the simplified equation, or into the simplified equation. If that doesn't work, simplifying the equation, there are no factors, there's nothing you can do with it. Part three is looking at the graph. So you just graph your function, look at what those y values are getting closer to as x gets closer to a. So let's look at a couple of examples. All right, the first one on the top left, the limit as x approaches 3. So first step is just plug in 3. We're going to get 9 minus 3 minus 1 over square root of 4. So that's over 2, 6, 5 halves. We got a y value. Okay, we plugged in the value of 3 into our function. That's our answer. We got a number. It's 5 halves. That's what the y values approach as x gets closer to 3. All right, looking at the second part, the second example here on the top right, as x approaches 2, you look at this domain, or look at the denominator, right away you can see you can't plug in 2. You got 2 minus 2 in the denominator, you can't divide by 0. So this is where we need to simplify. All right. We're going to factor. This is x plus 3, x minus 2, divided by x minus 2. Those factors cancel each other out. So now what we're looking at is the limit as x approaches 2 of the simplified equation, x plus 3. Go back to step 1. Plug in the x value of 2. 2 plus 3 is 5. That is our limit. Okay, that's what I mean by plug it in, don't get an answer, simplify it. Once you simplify it, then try to plug that number back in. So just to look at a graph, this equation that we just did, this is the graph of it. At an x value of 2, you can see the function is undefined at the x value of 2. So what you have is a little hole in the graph right there. But as x gets closer to 2 from the left side, and as x gets closer to 2 from the right side, those y values are getting closer to 5. All right, that's what we're looking for. Let's go back here. Okay, so now the next one. As down at the lower left, as x approaches 4, again with that denominator, you're not going to be able to plug in 4. You're going to be dividing by 0. So this one does factor. Doesn't look like it does, but if you look at that x plus 4 as a difference of squares, this is a weird one, like I had mentioned earlier. This denominator of x minus 4, it's going to factor to square root of x plus 2, square root of x minus 2. When we're just doing plain old factoring, we would just stop at x minus 4. Technically, we could go farther, but we're usually dealing with polynomials. Polynomials have integer exponents. The square root is an exponent of 1/2. So normally we didn't go to that, but it does factor. So then with your numerator, we got common factors. Those will cancel each other out. What we're left with is 1 over the square root of x plus 2. Now plug in that x value of 4. So square root of 4 is 2. 2 plus 2 is 4. We got a 1 over 4. There we go. Now let's go to the graph just to check it out. Turn that one off. Turn this equation on. Let me get rid of that stuff from the last one. As the x value approaches 4, we are looking at getting closer to 4 here and from this direction, from both sides. Here's 1. This tick mark right here is 1/2. You can see we're right there at 1/4. So the y values are getting closer to 1/4. All right, on the last one, this does factor x minus 1 squared over x minus 1 cubed. When we plug this, or when we simplify this, we're going to have 1 over x minus 1. So now when we try to plug in the limit, or plug in the value of 1 for x, as x approaches 1, we're still getting 1 over 0. So even though we simplified it, we still can't plug in the x value of 1. So the last resort is to look at the graph. Oops, turn that one off. Okay. So limit as x approaches 1. Well, we got a vertical asymptote at 1. So as x approaches 1 from the left, these y values are going towards negative infinity. As we approach 1 from the right, these values are going up towards positive infinity. So remember from yesterday, if a limit is going to exist, the y values have to be approaching the same number from both sides of We're not. We're going to negative infinity on one side, positive infinity on the other side. So what that means is this limit does not exist. Okay? If you want to mess around with any of these graphs, I put the link here. The link is on my site also. It'll take you right to this page, and you can mess with any of the graphs and take a look at them closer if you want to. Okay. So now, the other part of this is finding the limit as x approaches infinity, or negative infinity it could be. I'm going to do this in a separate video. There's a little bit of work in explaining to do this, and we're already at 8 minutes. So take a look at this second video.